Hello everyone. In this video we're going to be solving a polynomial equation. We have p of x plus p of 3x equals 16x minus 8. And we're going to be solving for p of x. Now if p of x wasn't a polynomial, it was just a function, then we would probably have more than one solution. And this equation might have more than one solution too. In some cases polynomial equations have more than one, but the solutions will be very limited. Anyways, think about the functional version of this problem and see if you can find other solutions besides the polynomials. So we have p of x plus p of 3x. What do we know? One of the most important things about polynomials is the degree of a polynomial. So when you have the degree of a polynomial as n, and let's say when you square it, you get 2n. When you add another polynomial to it, depending on what you add, you could get a higher degree, you could get a lower degree, things may cancel out, so on and so forth. When you multiply two polynomials, you add their degrees, so on and so forth. So rules of exponents are being used. But in this case, we're kind of adding two things of the same kind. So if p of x has degree n, okay, then p of, I should probably write this as degree of p of x, not just p. If degree of p of x is n, then degree of p of 3x is also going to be n. Why? Because replacing x with 3x is not going to change the degree. If you replaced x with 3x squared, that would change the degree obviously. But in this case, it's kind of like a linear transformation, sort of. So the degree is not going to change. So the degree of the sum is probably going to be n as well. I'm saying n would be the highest because things may just cancel out. But what we notice is that the degree of the sum is 1. So this is a linear sum. So I would say, okay, px or p of x must be a linear polynomial. Could it be quadratic? Possibly in some cases, but not in something like this. So we're going to start by replacing p of x with ax plus b, which represents a linear polynomial in general. A and b are real constants, and then we're going to go ahead and evaluate p of 3x from here, which is 3ax plus b, because you're supposed to replace x with 3x, and that's going to give you that. And now this sum is going to be p of x plus p of 3x equals 4ax plus 2b. 2b or not 2b. Now we know that this equals 16x minus 8, and now we have two polynomials that are equal for all values of x in the domain, and the domain is real numbers. Therefore the coefficient of x's must be the same. This is 16 and this is negative 8. Guess what? That's going to give you a equals 4 and b equals negative 4, which implies that p of x equals 4x minus 4. And that would basically one of the solutions. Now the question is there another solution for this equation? So here's the thing. Could p be quadratic? You can actually go ahead and test it out, the quadratic case. So suppose p of x can be written as ax squared plus bx plus c, and then p of 3x is just going to be found by replacing x with 3x, which is going to give you 9ax squared plus 3bx plus c. And when you add these two things, you're going to get 10ax squared plus 4bx plus 2c. Okay? 2c or not 2c, that's the problem. And by setting this equal to 16x minus 8, you're going to find the same thing. Because notice that there is no x squared on the right hand side, so the coefficient of x squared must be 0, which means a is equal to 0, which means a cannot be quadratic. A has to be linear. Make sense? Okay, and there is no other type of polynomial that will satisfy this. Therefore, p of x equals 4x minus 4 is going to be the only solution. Now we can go ahead and do some quick checks, such as since we were given p of x plus p of 3x as 16x minus 8, we can go ahead and replace x with something. For example, x equals 0 will produce P of 0 plus P of 0, which is 2P of 0 equals negative 8, from which we get P of 0 equals negative 4. And if you check that against P of x, that'll actually verify. It doesn't guarantee the solution, but it's a quick way to check whether we made any mistakes or not. Obviously, if you use more than one value, it'll be better, right? And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.